For a signal x of n equal to 2 to the absolute value of n that is given here for a range of n from negative infinity to positive infinity, question is which one of these choices A, B, C, D is the right region of convergence representation for the z transform of x of n. I'm going to show you that the answer is actually this one, meaning that region of convergence doesn't exist. So let's quickly do it. X of z equal to that's a z transform, sigma from n minus infinity to plus infinity, x of n, which is 2 to the absolute value of n, and then z to the negative n. That's the default definition of the z transform. Let's break it down into negative value for indices, 2 to the absolute value of n for negative value of n become negative n, and then z to the negative n, and plus for positive indices. So n from 0 to positive infinity and 2 to the absolute value becomes 2 to the n, z to the negative n. So if we further expand this or further just process it, we have minus infinity to minus 1 and then 2z just negative n, and then we have sigma n from 0 to positive infinity, and then we have 2z negative 1 and to the power n. Okay, I can do one other also change of variable before finalizing my decision. So sigma, if I just make a change of variable by just setting n equal to negative n, then what I get, or let's say m equal to negative n to avoid confusion, then what I get is become sigma from m equal to 1 to positive infinity, and 2z negative m becomes positive m. So that's only a change of variable that I did for the first sigma, and the second sigma is n equal to 0 to infinity, 2 times z minus 1 to the n. So what is the lesson learned here? We have infinite summation, 2 of them. For an infinite summation in the form of geometric series, in which if you check this one, it is start with 2, because m equal to 1 is a starting point, so it starts with 2z, next component become 2z to the power 2 and 2z to the power 3 and goes to infinity. If you want this to converge, then absolute value of 2z has to be less than 1 for a region of convergence for this geometric series. And that translates to absolute value of z, let's say less than 1 over 2. So that is the condition for the first summation. But look at the second summation here. It's again another geometric series, but n starts from 0. So the initial term is, or the first term is 2z minus 1 to the power 0, which is 1. The next term is 2z minus 1 to the power 1. The next term is 2z minus 1 to the power 2, and so on and so forth. So this goes on. And if you want this geometric series to converge, you need the common ratio, which is absolute value of 2z minus 1, to be less than 1. And to achieve this, it means you end up with absolute value of 2, and then, so basically that means 2. So you end up with 2 should be less than z. So absolute value of z should be greater than 2. So obviously when you can compare the conditions, and these two conditions should be satisfied at the same time, because you have the summation of these two infinite sums together. So at the same time you want absolute value of z to be less than 1 over 2. At the same time you want absolute value of z to be greater than 2. And obviously it's impossible to have both of them at the same time. Therefore, what we get is region of convergence doesn't exist, as is shown in choice D, and the rest of them not the right solution. I hope that this is helpful.